Good evening everyone. This is P. Sharwani from Data Science Department from Prasadri Patuluri Institute of Technology. So today my topic is the major task involved in data science. So before telling about the major task involved in data science, let me just give you an insight about what data science actually means. So data science is a science of storing, collecting, processing, modeling and describing of the data. So the data science main objective is to deal with all sorts of data and how we can structure them, store them, module them and give out to the end users. So here the five major tasks of data science are collecting of data, storing of data, processing of data, describing of data and modeling of data. So these are the five tasks, the major five tasks involved in data science. And here I am going to tell about each of these. So the first one is collecting of data. So collecting of data is actually means collecting of data from different sorts of resources available for analysis. Analysis as in we see the insights of our data and will know if that data is produced properly or not. So here to collect the data for analysis, we have some certain requirements. So there are three techniques, three cases which we are required to see this. So the first case is data available within the premises. Example like Amazon and other online platforms. Here the customer data is observed and we get the recommendations accordingly. Like for example, if we look at if we open WhatsApp or Instagram or Amazon and if we look for certain product, the next day when we are scrolling to that website, we look at some different similar type of products because we have looked for them. So this is all done because of the data science, because they know our interest, they calculate our interest and view us our required ones. So here data is available and collection of this sort of data is easily done by using the SQL programming language. So coming to the second case, that is data available not within the premises. So best example for such case is that example like political surveys. So if we look at some political surveys, we don't have any particular data source where we can get the information from, but we can analyze it using the APIs. API means it's an application programming interface. So it is an interface which acts as a mediator between two applications. So here we use data from different social media and third-party platforms to extract data for our model. So coming to the third case, it's data not available. The best example for this is like the farmer crops. Here we can't use any data, we don't have any data. So what we do is that we use some experimental and statistical ways and do some testing on that data. So this is about collecting the data. So coming to the next major task, it is storing of data. So storing of data means generally the storage of data is done in the hard disk of the computer. But if we are talking in general, if we are talking about the structured data is stored in the database management system. So here also there are some three ways involved in storing of data. That is transactional and operational data. Here where the structured data is stored. Like this data we can easily store, access and retrieve the data here. And one of the major things involved here is like we can get the day-to-day row and column wise information. It is like very structured and we can easily access them. Even we can update them. Example like patient records for example. We have the date of the date of the discharge and what sort of medicines, who is the doctor assigned for. So this is an example of transactional and operational database. The major point involved in transactional operational database is the relational database. So relational database is where the structured data is stored and we can easily update and insert the data here. So coming to the next one, that is the data from multiple databases. So the data from multiple databases, we use it for analysis. So the next major case involved in this data from multiple database is the data warehouse. So data warehouse is a collection of different heterogeneous operational data. So here the data is like, it's a time variant, it's non-volatile. Non-volatile as in we can't update it, it's read-only data. So example of this data warehouse is like FDs, bank accounts. Like previously when we took the example of patient records, like we can have the row to row, column to column, day to day information stored here, but here it is only limited, like the FDs, bank accounts, etc. So coming to the third case, it's the unstructured data. Unstructured data is like initially we collect some data and we dump the data when it is required. Example of such sort of unstructured data is like text, video, audio, and image. So here these sort of data have a huge variety of velocity, variety, and volume. Velocity as in like how big the data can be transformed, and volume as in how big the data is, like how much storage it consists of, an example. And coming to high volume, it is like how much big data it is available. Variety as in different sorts of data, and velocity is how fast the data can be transformed. So this data, like the high velocity, volume, and variety, this all is known as the big data. So the big data is processed using the data lakes. Data lakes is the main concept here in unstructured data. So to sum up the storage of data, it consists of three main topics, that is relational database, data warehouse, and data lakes. So let's see the next big task involved in data science, that is processing of data. So the main objective of processing of data is to improve the quality of data that we hold for analysis. Like here it is where it is refined, the data which we collected so far. The main objective here is to just improve the quality of data for better usage. So the process, the one of the main concept happened here is data wrangling or data bundling. It consists of four techniques. The four techniques involved are filling the missing values. Like initially when we collecting the data, some of the values can get missed. So here we just fill in that missing values in order for analysis. So the second is removing noises. Noises is like a random error or variance in the measured value. So at the time of collecting data, the data can have noises. So we try to remove these noises for the analysis. So the thing for removing the noises is like actual data minus calculated data is how we try to remove the noises. The third one is identify and remove outliers. Outliers is like from normal object property, if it deviates, then that is known as an outliers. Like if there's a huge difference, or if some attributes have irrelevant data, that is known as outliers. To understand outliers, the best example we can say is like fraud detection. That is the best example for outliers. And the third one is data transformation. Data transformation is like transforming the data we have into whatever format or a particular format we need is known as data transformation. So these are the four main techniques involved in processing of data. And the main objective of data processing is to just improve the data that we have for a better experience for the end users. Coming to the next major task involved in data science, that is describing of data. Describing of data, nothing is to understand the data we hold. Like if we don't understand the data, we just don't have to, we can't sell it in a efficient way, or we can't make others understand it if we don't understand it ourselves. So the main objective of the describing of data is to understand the data we hold and to describe it in an abstract level. So the first major task in the describing of data is visualizing data. Visualizing data examples are here. We use bar graphs, pie charts to visualize the data. That means we plot the data and observe the distribution of this data and try to understand this data and apply some appropriate analysis on them accordingly. This makes the users and us involved, like at which aspects we are distributing the data, and helps us understand our data which we are holding in a more efficient and abstract level. So coming to the next task, that is summarization of data. Here we use methods like mean, median, mode, standard deviation, and variance. These are some powerful techniques. We use these powerful techniques on the data to summarize the data which we are holding. Here also describing data is also known as an iterative process, because we throughout try to learn the data that we have. So here we can see the pie charts, line graph, bar graphs. These all come under visualizing the data. So going to the last major task involved in data science, that is modeling data. Modeling of data is nothing but at the time of end evaluation, we'd like to model our data accordingly. So we can describe modeling of data as like establishing a relationship between our input and to the business objective is known as the modeling of data. It consists of different mechanisms. Like if we look at it, data modeling is a process of creating a visualized representation of either a whole information or parts of it combined. Like we either try to make sense of the whole information or just a part of it which we have. So coming to the major techniques involved here, statistical modeling. Statistical modeling, we know about statistical algorithmic ways. So this is the types here in modeling of data. Statistical modeling is this, the modeling underlying distribution, like the normal distribution. We use statistical models on simple models like statistics and low dimensional data, which involves no complex data, which can be easily done. So the statistical modeling focus main on interpretability. Here, modeling underlying the differences, the relationship between the data. Coming to the algorithmic model, here algorithm modeling used for complex data and high dimensional data. Here we use the algorithmic modeling for complex data involving the data which deals with the machine learning and deep learning. And also here we use some high dimensional data like big data. Here we use it in the. This model mostly focus on prediction. So the statistical modeling mostly focus on interpretability and the algorithmic model mostly focus on prediction. So to sum up the modeling of data, to understand the statistical and algorithm model, to establish some models, to build some models in both of these modeling techniques, we use linear regression and logical regression. These are the main two methods to develop models using these both ways. And also let us look at some of the skills required if we are going to modeling of the data. The skills required are, we have to have some knowledge on the Python framework like the NumPy, Pandas, and we have to have some knowledge on deep learning and machine learning, and also we have to have some knowledge on the probability theory and inferential statistics are some of the skills required to understand the modeling of data. So these are the major tasks involved in data science. So at least if a data scientist at least goes to any of these different major tasks of data, like if a data scientist focus on any one of these major tasks, then they can success in that particular models, because these are the 5 major tasks involved in data science. First if we look at this picture more carefully, like if the input data, we do with some machine learning algorithm, we used it, and we use some prediction to evaluate it, and therefore we train the data, and that forms into an machine learning algorithm, we get the last model. So this is modeling of data all combined. And that is the end of today's my topic, and thank you.